Te cuento Puede estar escuchando.
So, dear colleagues and partners, I propose that we slowly start our today's session. I'm very glad to come back to this kind of communication because it's very important to exchange thoughts and ideas and status of what is happening in agricultural market in different regions, because only then we can be most helpful and to you with that solutions which we can propose. So what is no, first of all, again, I'm glad to see everybody, and I would ask you to be active first of all in chat. So please write in chat where are you looking us from today. For example, I'm currently in Slovakia, and my colleagues from in our chief office in Kiev. So where are you from now? Please share it with chat. It's interesting to see where is our audience from. For example, I see already the message from Uganda, Romania. As far as I know, there are Bulgarian colleagues here, also from Spain, Serbia. What other we have directions? I see Romania as well. I see Belgium, Chile, Austria, United Arab Emirates. It's great to see Zambia, that we have so diverse audience today. So okay, let's move closer to the topic. So what is the topic and why we choose it? As you know, BTU is a factory from Ukraine. We are experts in biofertilizers, biostimulants, and bioprotectants. I will tell you a little bit more about us later. But what is important, we work a lot with different regions. We work with partners, we work with farmers as well. We communicate a lot, and we know that, for example, in Europe, in agriculture, this year is not an easy one. There are difficulties for farmers in liquidity, in prices for the grains, in general situation on the market, in regulative aspects. That is why we understand that this year is quite challenging for farmers, and we would like to exchange our ideas of what farmers can do to improve the economic efficacy of their technologies, and what is our experience in this, and yeah, how farmers can earn more with minimum investments. So today our webinar would consist of 3 parts. First of all, I would start with some kind of brief introduction of what is happening on the market, first of all in Europe, and what in general ideas or directions of solutions we have to address these regional and global challenges on the market. Secondly, we are very happy to invite our expert Yaroslava Buchonska to tell us more deeply what are those solutions. Actually, she would speak about carbon farming. She will speak about nutrients mobilization. She will speak about stress tolerance, the ways to preserve the yields with biological tools. But from the scientific point of view, to understand what actually we could do with plants or with soil. And then my colleagues Dmitry and Alexander would exchange or describe their experience, practical experience from fields, from work with farmers, of what can be done to improve the economics with examples of and calculations. So let us start. One moment. So first of all, what happened on the market in of fertilizers last year? Of course, you all understand the regional situation in Europe with Russian aggression in the region. So it influenced a lot both previous year, but this year as well. But what is interesting for agriculture on the example of this slide is that situation was predicted to be even worse. I mean, for the demand of fertilizers, but in fact, demand of nitrogen was a little bit declined from the previous year, but in terms of phosphates and potash consumption, it even grow faster than it was predicted. So actually, agricultural market is alive, and in terms of fertilizers, it grows. What happened with the prices and where are the prices of main fertilizers? Here you can see a lot of indexes of different kind of nitrogen, phosphorus, and kali fertilizers. And the main idea is that more or less they all jumped after Russian aggression to the high and quite extreme level. But sooner or later, different kind of fertilizers decline to almost like normal conditions as they were like before the COVID crisis and before Russian aggression. So more or less prices of most of fertilizers now is stabilized. It's not on the minimum, but still it's on quite adequate level. Talking about the fertilizers consumption, I already mentioned, yes, that for nitrogen we have some decline, and we can see that it is predicted that still nitrogen fertilization will not grow so much. It will keep more or less on the same level during next 10 years. Talking about phosphates and potash, also there is some growth predicted, but it's not dramatic growth because again, agrotechnologies are quite mature in terms of fertilizers, and we don't speak about the volumes, but we more speak about the quality and efficiency of fertilizers, about the technologies of fertilization. It's both about like granules coating, or it's about some special forms of fertilizers, liquid water soluble fertilizers, but also about biological tools to improve absorption and efficiency of fertilizers. So if we speak about the regional situation, you can see that for most countries, more or less, fertilizers are predicted to grow, especially phosphorus and potassium. But if we speak about nitrogen, a lot is because of the regulation, because again, nitrogen evaporates, and in a lot of countries where animal direction is developed, it causes problems, like in the Netherlands, for example. You can see there is some decline predicted, but it is caused a lot because of regulation, some limitations of use of nitrogen. And actually, it's also important for us to see these dynamics, because we understand if farmers cannot, for example, in Ireland, Italy, and Netherlands use nitrogen fertilizers, they need some tools to compensate it to get sufficient yield. And here we could use some alternatives like nitrogen fixing microorganisms, etc. And we are very happy that in most of these regions where there is a biggest decline, we are already proposing farmers such solutions. Talking about use of fertilizers by crops and some predictions, you can see that again for nitrogen in most crops there is a decline. Just in seed rape there is growth, probably because it's a very how to say high-end or expensive crop, and farmers want to maximize the yields. But again, interesting is that in phosphorus and potash for most crops it is predicted to use more fertilizers, and just maybe differences in no, and interesting is that in potatoes there is some decline predicted, and also in grasslands. I believe important reason of this decline is also limitations of by legislation. Talking about change in farming crops, it's also prediction of European Association of Fertilizers. It is interesting that wheat, which is quite a traditional crop in Europe, could be declined in hectares, but still there is some perspective in improvement of the yield using again more efficient fertilization schemes. Interesting is that in opposite to wheat, barley areas are going to grow. Rye, rice, oats decreases in no, similar to wheat, decreases in area but increase in the yields. Very interesting is about the grain, because the areas are predicted to stay more or less the same, but it is still predicted that farmers will succeed to increase productivity up to 10%, which is quite a lot, taking into account that nitrogen fertilization is limited. So here we also have a lot of very perspective solutions to increase the yield of maize, like for half of ton, sometimes up to ton, with biofertilizers and biostimulants, and we believe we would help this prediction to happen with these technologies. Similar situation about potatoes, that areas are decreased, but yield are going to improve. And also rape, again, crop areas are increased. It is a valuable crop, and still there is a belief in improvement of technologies. Talking about the prices of grains, here you can see that indeed prices for wheat, for example, are not as high as it was during last 2 years, but still you can see that it is more or less adequate level. It's not some historical maximum, but it's on the level as it was before the crisis. That is why no, I believe that more or less it's still is economic efficient level. The similar situation is about corn. You can see that steel prices is quite high. It was lower, quite much lower 4 or 5 years before. Of course, there was a period of high prices, but agriculture is always a volatile market and cannot stay on the very high level for a long time. And talking about the rapeseed, similar situation. It's not on the top level, but still it's like on the more or less average stabilized market. So we can say that prices of commodities are now quite stabilized. They can volatile, but to both sides. Also, there are trends of decreasing carbon evaporations in agriculture. This is about again Association of Fertilizers Europe. And on this level, producers of fertilizers in Europe look how they can decrease carbon evaporation in the technology. But we also have some ideas in these directions, and I'm happy that Yaroslava will tell you more about this in next presentation. So to generalize what trends we can identify on the fertilizers market, we group them to different categories. So talking about market, we can say prices stabilize for fertilizers and there is slow growth of demand. We can say about some risks also about the high logistics costs because it's regional problems, Russian invasion, but also some conflicts in Middle East, but also different situations in the region increase logistics risks. Also, there is some decreased demand in East Europe because of challenges in weather. Again, it's climate change. It's very long arid periods of drought, but which is followed by short periods of big amount of water with floods. So this is a situation we, for example, have seen this year in Balkans, especially in like Greece, Italy also, but also in Germany. And we also work in the direction, for example, to recover soil biological functionality after floods, but it's a little bit different topic. So also some political risks, of course, we already mentioned some of them, and we understand that market try to adopt to this change. So there is supply chain diversification and industry tries somehow to protect itself from the different situation. There is a regulative part, which means that we have a Green Deal in Europe, but you have seen that nearest few days ago, just there were some decisions on the EU level for SUR program. I mean, for program for support integrated approaches, and some of the chemicals like glyphosates are prolonged for use. So there is a positive direction of change in agriculture. I mean, like Green Deal, but still there are challenges of these initiatives, and these challenges slow down this progress. But still, there is a support from Europe for regenerative practices, for ecological practices. About talking about the ecology, again, we are on this market 25 years, and during recent 7-10 years, we are active in Europe. So we see better and better perception of ecological practices by farmers. So farmers indeed want to improve soil health, and they want to grow healthy vegetables and yields. That is why they more of them prefer organic and bio-based solutions. And also there are these solutions allow to decrease carbon evaporation and other harmful substances. So we also see a lot of attention to soil health and biodiversity on different events like Farm to Fork or Soil Biodiversity Congress or another one. So this topic is trending, and really it is a very good sign that both politicals and farmers and industry wants to preserve soil healthy. And there are some technological trends like biofertilizers and some alternative solutions, improved efficacy solutions become more and more popular. Precision farming, again, for more economic use of these technologies. Starting fertilizers, also nitrogen inhibitors are quite more and more popular. We see, again, some inefficiency in intensive use of fertilizers in some regions. For example, we will see today some trials where increase of fertilization rate didn't increase any yield, which means that it's not efficient to use more and more fertilizers. It's more economic to use some improvement in these technologies. And we see that there are some, again, this leads to innovations in fertilizers. There are a lot of fertilizers producers. They want to differ from each other. They want to have a better value for customers. That is why there are projects, and we have some to, for example, enhance fertilizers with some biological solutions. So that's all for the market overview. Now I will tell you just in a few words about us and give a word to my colleagues. If you have any questions to the previous blog, please write them in the chat, and after my presentation, we will try to answer them. So talking about the BTU, I mentioned we are a 25 years company from Ukraine. We work in 3 businesses. Agriculture is our main one. Also, we do some products for human health, and we do some products for oil industry, for example, to recover soil polluted by oil wastes. In general, company have more than 500 people. We apply our products on more than 4 million hectares, and we do thousands of trials, and we analyze the big data with different tools to be very confident what we can expect from different solutions in different conditions. We are present up to 20 countries, mainly in Europe now, but we have some projects in Latin America, in North Africa, and we are inviting you and new colleagues from different parts of the world. We are open to exchange our experience and our solutions. Separate direction is home and garden. We also propose biotechnologies for people to use at home. And we work a lot with scientists to understand what actually our products do. So what challenges, global challenges we would address with biologicals? One of them, and quite trending, is carbon management or carbon farming. And here we have a solution to enhance carbon sequestration process and in general improvement of soil functionality and properties. We work with phosphorus and kalium solubilization in soil with the product GroundFix. Here we have more than 600 trials with different approaches to integrate it into technology, like just soil application with incorporation, without incorporation, with herbicides, with fertilizers, very different, and some of them you will see today. Also, we work with nitrogen fixation with AzotoHelp, which can be applied both polarly or into soil to compensate lack of nitrogen nutrition for plants. We have Liposam, which is a tool to preserve efficiency of both chemicals and fertilization, and also it acts as anti-stressant. And in general, we work with some anti-stressants to help plants grow in drought conditions, in salinity conditions, and flood conditions, and others. So in this direction, we also collaborate with different organizations internationally. For example, we work with Biotrax, which is a Japanese technology to assess soil biological activeness. We, for example, run with them projects in Germany, in Poland, we are going to run in Greece, in Italy, in Romania, and of course in Ukraine. So it's quite a perspective technology. Carbon Safe is a Bulgarian organization which is active in carbon farming. So with them, we study some of our solutions like EcoStern and HumiFriend to accelerate carbon sequestration. Some European project we have in Slovak Republic, also to assess influence of biofertilizers, EcoStern, to soil health indicators. CO2 Land is also a German organization which promotes regenerative agriculture ideas. And I will mention also Bulgarian Institute, with whom we already study some of our biostimulants against drought tolerance, but with which we have big plans to continue research in Czech, in Bulgaria, in direction of implementation of different biosolutions in agriculture. So that's all from my side. Now in a few minutes, I will give a word to my colleagues. So if you have any questions during the following time, please write them in the chat. So Yaroslava, do you hear us?
Yeah, sure. Hear you. Do you hear me?
Yes, we hear you.
Great, 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 great. Do you see my screen? And one more moment to check. I have to check if my slides are changing. So you see only the capital slide, yes.
Yes, we see a capital slide, and I'm sorry, maybe I will not interrupt, but comment a little bit during following presentations, just as audience representative. And first of all, I very appreciate and enjoy this picture on the slide. So can you tell us a few words what you wanted to show here?
Primarily, I wanted to show on this slide that microbes are key organisms which interact with plants and create one single system, a holistic system with them, and that microbes and plants are crucial for our living on Earth.
So it's a universe below the soil.
Yeah, it's a universe, yes. It is a small universe of microbes and plants on our planet, and we cannot exist both without microbes and without plants. So our life totally depends on these two kinds of organisms.
Okay, Yaroslava.
Yes.
So try.
Yeah. I will continue. So just a few words about key topics I will cover in this lecture. So first of all, carbon credits. A few words about them because they are emerging in the world, and it's very interesting to know a little bit more about them. And also why soil organic carbon is so important for us and, of course, for our plants. The second one is more centered on microbes, and in particular, how they can enhance soil carbon sequestration and help us with that. The third point is how to improve plant nutrition with microbes and how to feed plants less, and at the same time make them eat more. And the fourth part is about plant growth-promoting bacteria, which are very interesting organisms with multiple functions. So let's continue. First of all, about carbon credits. We all know about global climate change, and we also know that different countries and companies all over the world are taking measures to decrease CO2 emissions, which is known as one of the main causes of global climate change on our planet. And it is very important to mention that plants and soils, so ecosystems where plants are grown, have very high potential to absorb CO2 from the atmosphere. Frankly speaking, plants can be named the best carbon sequestrators on Earth because they use CO2 to build their organisms, to build their bodies. And after plants' death, these plants' parts are decomposed in the soil with the help of microbes, and these compounds are left in the soil and form organic matter. So how carbon credits work? When we have a company or organization that has high CO2 emission and they want to decrease that emission to compensate it, they pay some particular amount of money to companies or organizations that can decrease the content of CO2 in the air, in the atmosphere, by sequestrating it into Earth. We are talking about agriculture, not about our other spheres. And so certificate for sequestration of 1 ton of CO2 is named carbon credit. What about prices of carbon credits? Several years ago, they used to be quite cheap. And now we can see that their price is rising and rising each year. And we will talk about these numbers a little bit later. But now key organizations in carbon farming in the world are assuming that this price will be rising and rising, and the price of CO2 will be more and more for those people who emit it and for those people who sequestrate it. So how carbon sequestration is calculated? There are a few companies in the world that are doing it. So these are companies to whom companies who want to decrease their emission pay. And after that, this company, for example, Agrina, pays this money to farmers, to agricultural producers for sequestration this CO2 from the atmosphere. And to calculate how much carbon was sequestrated during the growing season, precision agricultural tools are used, starting from soil samples collection, of course, to analyze for soil organic matter content on this part of land. And of course, using satellites, image agro drones to monitor which crops are grown. Do you use cover crops? Which kind of crop rotation do you apply? Do you leave plant residues on site? And so on and so forth. So you can see that technologies are quite developed in this area. And a little bit about carbon mass, how it is calculated. So according to 2023, to the previous year, Agrina claimed that they paid on average $32 to $36 per hectare to their clients, and it was approximately for 1 ton of CO2 sequestrated per hectare. So it was the price for the year before, and they expect that in this year carbon CO2 will be more expensive due to more severe carbon regulations, climate regulations. So following calculations. So in 1 ton of CO2, there is 420 kilograms of pure carbon. And when we're talking about soil organic matter, it contains approximately 58% of carbon. So each ton of sequestrated CO2 is approximately 720 kilograms of soil organic matter per hectare. And if we're talking about agricultural soils, soil organic matter content in them generally ranges from 1 to 6% in the topsoil. And what we call topsoil is a layer of 30 centimeters, and we can assume that it weighs approximately 3 million kilograms per hectare, plus minus, it depends on your soil type. So depending on soil fertility, soil organic matter weight can be estimated from 30 to 180 tons per hectare in the more rich soils. So when you add each year 100 kilograms of soil organic matter, it means only a minor increase of total soil weight. It ranges from 0.4% to 2.4% if you added extremely high amount of soil organic matter. So these are not impossible changes. It is actually very real to achieve these results, and we will talk more about how to do this. And a few words about agricultural practices, because different organizations which work with carbon credits, they not only analyze soil organic content, they also pay attention which other practices you're implementing in your farm. And we know that agricultural practices have a problem that they may increase losses of carbon while tilling and taking all or most of organic matter with crop and its residues, and at the same time we decrease carbon input. So we increase output and decrease input, and that's why we have a negative carbon balance in soil. And there are 3 key practices to introduce. First is conservation tillage, to reduce tillage to minimum tillage or no tillage at all, to protect soil from losing carbon through oxidation, because when we till, we give access to oxygen into the soil and it causes organic matter to decompose. Second part is cover cropping. What cover cropping does is basically we grow more plant biomass and we leave it on site, we don't harvest it, and that's why all the sequestrated carbon is left in this soil. That's very good actually. And also Besides cover cropping, it is very important to leave as much plant residues on site as it's possible, to leave all the sequestrated carbon on this place. And the third approach is to apply organic fertilizers like compost, for example, as additional source of carbon. It works very well when the farm is connected in animal husbandry and plant material production. Why microbes are so important in this process? Because with microbes, all the sequestration process is impossible because we have a huge microbial factory in our soils, which decomposes all the molecules of plant origin, of animal origin, and they form different carbon compounds and they deposit it in the soil with the help of sophisticated biological reactions. And actually, it is a very potent factory, and we cannot do anything in carbon farming without soil microbes. So it is very important to sustain high microbial activity and high microbial diversity in earth, in soil. And it is also very important to mention that soil organic carbon in the soil is stored as soil organic matter, but it is very dynamic system. So microbes are constantly adding new substances into soil organic matter, and at the same time, it is used by other microbes in the process of metabolism. And people often, when they see that soil has high respiration rate, think it's very negative, but I would say that it's very positive because it means that soil has high biological activity. It is respiring, it is working on both processes, and the more microbes work, the more carbon will be sequestrated in the soil at the end of this process. And it is very important to mention. So many people pay attention to carbon farming only in terms of climate change mitigation. But when we're focusing exclusively on climate change mitigation, we almost forget about other beneficial effects, such as improved water holding capacity. We are reducing erosion and improving nutrient availability and increasing biodiversity of soils. All these effects are crucial for helping plants to thrive through climate conditions changing and to improve the value of soil. So not only climate change is important, but also there are very great consequences of increasing soil organic matter content in the soil. And how microbes, let's pay attention, how do they do increase the carbon content in soil? First of all, it's microbial necromass. What is necromass? It's when microbes are living in soil, they're doing their metabolism, they're eating plant residues, and after their active biochemical life, they die, and they decompose, and they form necromass. And in this form, they are stored in soil, and it's a great form to deposit organic carbon because in this process quite stable metabolites are formed. These compounds are quite resistant to degradation, and it is very important to have abundance of microbes in soil so they can first of all decompose different substances of plant origin, and on the secondly they can die and leave this material in the soil, because no single compound in soil can be transformed on its own. You always need microbes to do this job. And the second very important function of microbes in soil is creating a structure. because soil is made of tiny aggregates. The smallest aggregates for bigger aggregates, and as a result, they form soil structure. Unstructured soil is a desert. So aggregates are very important for soil fertility, for its water holding capacity, and this is microbes who sustain this process because they form different compounds that bind these small particles to each other and to form that pretty nice aggregative formation in the soil. And it is very important to mention that deep plowing, deep tillage breaks the form structure, and it is very important in terms of carbon farming and increasing organic matter content in the soil to reduce tillage and to plow the soil and interrupt the soil surface as as less as possible. And the third mechanism, how can microbes enhance carbon sequestration, is plant promotion of plant growth. So there are endophytic microorganisms that microorganisms. Sorry?
1 second.
Yeah, please make sure that you're muted. So yes, not to interrupt. Okay. And so there are a group of microorganisms which can colonize plant tissues and to synthesize growth stimulating substances which stimulate root system growth, which stimulate vegetative part growth, and that also contributes to carbon sequestration because the bigger plant biomass we have, the higher potential it has for photosynthesis and of course for carbon sequestration and carbon deposition in soil. And of course, when we have abundant and diverse microbiome of soil, we can be sure that it will do its work correct, and it will accumulate all these carbon compounds in the soil. And the next part of my speech will be dedicated to nutrient transformation, and let's talk about key nutrients. We know that nitrogen is essential element for plant growth. No proteins and amino acids can be formed without nitrogen. But the paradox is that nitrogen is present in the air in a huge amount, but it cannot be used directly by plants, unfortunately. And there are bacteria in the soil which are called diazotrophs, which are able to transform this atmospheric nitrogen into the form which is available for plants. And these diazotrophs can be of two types. The first is symbionts, the one which forms symbiosis with legumes called rhizobia. And the second kind of bacteria are free living, and they can live on different species of plant and fix nitrogen for them. The second deficient nutrient is phosphorus, and it is very deficient in soil because it is available for plants in just a small amount. Even in most soils, phosphorus stock is great, but only a minor part, smallest part, is available to plants. And the same situation is with potassium. 98% of potassium stock in soil is unavailable to plants. So potassium and phosphorus are these key problematic kind of nutrients for plants. And what microbes do? They synthesize organic acids which dissolve insoluble, unavailable phosphorus and potassium minerals and leach them into the soil and make them available for plants in this way. And speaking about trace elements like zinc, copper, iron, bacteria also work on making them more accessible for plants by synthesizing siderophores. Siderophores are natural chelators, which react with these trace elements and help them to transfer them into plants' roots. And in this way, they make them more easily accessible from the soil. And speaking a little bit more about phosphorus, we know that in previous years we have added lots of phosphorus fertilizers into the soil, but the truth is that it had quite a low efficiency because up to 90% of added phosphorus is quickly immobilized in soil and made unavailable for plants because it's very fast because of very fast absorption process on the surface of soil particles. And we have to shift the paradigm from not adding more phosphorus fertilizer, but on making it more available for plants and for utilizing the phosphorus which is stored in the soil. So on the right side of this picture, you can see bacteria which are working to supply plants with phosphorus. And it is very important to give enough nitrogen and carbon for these bacteria to feed and to make them work efficiently and to be abundant in soil. And in this way, we can indirectly significantly improve phosphorus nutrition. And in the next presentation, my colleagues will cover this topic more. And some words. It is very important to mention that bacteria are not volunteering in soil. They are not being kind creatures which came here to help us to grow plants. They first of all do it for their own needs. They mine phosphorus from the soil with the help of organic acids to assure their metabolism. So it is very important to have high biodiversity in soil and high microbial content in soil to have enough phosphorus available for our plants. And here you can see two possible mechanisms of improving phosphorus nutrition. First of them is when bacteria dissolve soil minerals and excrete phosphorus directly to plants. And the second scenario is bacteria do it for their own needs. They absorb it, and after their death, this phosphorus is released, and after their death, plant can finally use it. And our fungal assistance in improving plant nutrition is mycorrhizal fungi. What they do is they increase the surface of root system and they increase the area from which roots can uptake phosphates and other crucial nutrients. And what they also do is they increase the potential to they increase the water availability because of increased surface, and it is very important for plants during drought stress when the access to water and water supply is limited. It is very good in increasing plants' tolerance to drought. And summarizing a few mechanisms, how do plant growth promoting bacteria, PGPB, do their work? First of all, they synthesize growth-stimulating hormones, which stimulate both growing of vegetative part and root system, increasing root length and shoot length. And what they also do is they solubilize nutrients, especially phosphorus and potassium and some trace elements also. They can fix atmospheric nitrogen and synthesize siderophores to improve the availability of trace elements. And what they also do is they synthesize biologically active compounds which increase plants' tolerance to abiotic stress, and also they have a mechanism to increase plant systemic resistance against different pathogenic fungi, bacteria, and other pathogens. Here is our scheme where we summarize the effects which microbial stimulates can do against abiotic stress. So on the left side, you can see some adverse effects of abiotic stress in plants. And on the right side, you can see how microbial stimulates can help us mitigate it. So it's both growth promoting hormone system synthesis and decreased ethylene production and increased photosynthetic rate and increased defensive systems of plants activity. And it is always very important to keep in mind that biological have more than one way to help plants thrive compared to synthetic plant protective products, which usually have only one mechanism of action. Biological always have different ways to help us. So I hope it was interesting for you. I will be happy to hear your questions. And thank you for your attention. Feel free to contact me if you will have some new questions.
Yaroslava, thank you very much for the presentation. And while people are thinking about the questions, please write them in the chat. I would like to have some more discussion. So you worked during last, I don't know, months, years with our group of agronomists as well as with farmers. Could you say what of mentioned topics are the most frequently addressed by requests to you? So what you hear from farmers, I mean, what they are interested in most of all now from this direction?
Okay, so from my experience, I would say that almost everyone is interested in nutrition, in plant nutrition, because fertilizers price is rising, and they want to reduce fertilizer input without losing the yield. So potassium and phosphorus mobilization and increasing the efficiency of this nutrition are key questions. And also nitrogen fixation is very interesting to farmers, and also biostimulants, because we know that microbes have a great potential to stimulate plants, to boost their productivity, to boost their tolerance. And this is particularly important because we are living in times of global climate change. We can see extreme temperature, droughts, floods, frosts, and all other kind of cataclysms. And we need to help our plants to thrive through this difficult condition.
Thank you, Yaroslava. Also, I would like to ask you, 2 months ago, we were on World Biostimulants Congress in Milano, and you also were represented some of the solutions for improvement of plant tolerance to abiotic stresses. So you also communicated from with scientists and industrial companies from all over the world. So what were the discussions over there? I mean, what people are interested in on this level about this topic?
Because my poster was dedicated to drought stress tolerance, it is not surprise that many people from Asia and African countries were very interested because they have such problem. And yes, I would say that people who already faced the most severe consequences of climate change were the most interested, but also people from European countries and also America were interested. And there, I can remember speaking with one farmer from the United States. He said that Wisconsin, in his opinion, is kind of similar to Ukraine, and that our results can be uh, used to also help him in his work. So, and also there were many people who were interested in plant residues management. No matter it wasn't covered in the poster, but many people asked because I mentioned that our company has products for it. And the very interesting question was how to manage plant residues in drought climate, because microbes need a lot of moisture to do their job, and it's
Do you
actually a
have
very good.
any answer for this question? It's not an easy question.
It was very interesting discussion from a farmer from Egypt. He told that they have no other decision than to just to burn their residues, because they don't have moisture to decompose their residues. Maybe I would say that in this case it can be beneficial to compost residues. I understand that it is way more expensive, but when you cannot decompose your residues on the site, you may try, if you have enough resources for that, to do it somewhere outside. But yes, it's very, very, very difficult problems. Maybe application of some microorganisms which can form biofilms, which hold water and may slightly increase water retention capacity of the systems, but still, when there are no rains and the air humidity is extremely low, mm, and you just cannot even accumulate it, you have no source from where to accumulate it.
Yeah, so maybe also the idea could be to apply these biodecomposers during vegetation period in drip irrigation or in fertigation, because plants also don't grow without moisture. So there is a period when they provide some moisture, and that could be the period when microorganisms could work more actively in at least in the rhizosphere zone to provide better
Yes.
growth. But yeah, we need to think it's a challenge, and we don't say how to say, we don't say about any, how to call them, like one solution to solve all problems. So we are specific, but yeah, sometimes challenges are not easy. Okay, Yaroslava, thank you so much for the presentation.
Thank you.
And for the audience, please write your questions, if any, to the chat, and we would be able to comment them. I have seen some presentation about sharing of presentations. So of course, for the participants of registered participants, we will share some materials after. So moment. Now I would like to give a word to my colleagues from with a huge experience, practical experience in use of biologicals in different regions, in different technologies. And I would ask them to focus on economic side to comment what exactly can farmers do and how much they can earn using this or that solutions. So Dmitry, Dmitro, to be correct, are you ready to join?
Yes, of course. Do you hear me well?
Yeah, I hear you well.
Oh, great. So, do you see my screen?
Yes, I do. I see the top microbial products slide.
Yes, yes. Everything is. So, I hope that our part will be also interesting like previous part, because we have practice truths about microorganisms and about our products. And we will discuss today, we will discuss all these products, a little more information about these products. Ecostan, it is biodestructor. Liposam, it is bioadhesive. Crown Fix, we use like PK mobilizer. Azotohelp, it is product for one second. Azotohelp, yes, it is product for fixation of nitrogen, and also trend of the whole market. It is mycorrhizal product. Our name of this product is microplant. As you can see on this slide, we have a lot of trials with each product. Sometimes we have around a little more than 200 trials. Sometimes, like with liposome, we have more than 800 trials. Also, in this part, you can see how many trials from all of them we have with very big, very good results. And also we use these products, as you can see, EcoStem and liposome we use for more than 2 million hectares, and this product a little new than previous, and we use these products more than 150 thousand of hectares. And also all these products can provide us some increase in the money from each hectares. And also these products, as you can see already, we have already in 14, 12, and 11 countries. It means that we have registrations for these products in EU and other countries. And we will start with one trend topic for now, because agrotechnology from our side, it is nitrogen fixator. As you can see, as you know, we have a lot of the same products on the market, but our product agrotechnology based on agrobacterium pucens, and also we use this product like for seed treatment, for foliar treatment, and also for soil treatment. And also I would like to draw your attention on title of this product. It is very big concentration, because we have amount of bacteria more than 1 billion per milliliter of product. It provide us less amount of low rate of this product for our crops. Very important question is how we can check that this product works. Usually, first step for check of this efficiency of this product, it is visual effect, like on these pictures. Left side it is control, and right side it is trial. As you can see, our vegetative mass bigger and better. The same situation with root vegetables like potato. It is from control. As you can see, we have maybe the same numbers of potato, but we have smaller potatoes than from our trial. And also about rapeseed or other field crops, we already see visual effect, like how our products can influence on development of plants. And also we have enough trials, and we can say about this product can provide us up to 60 kilograms per hectare of nitrogen during season. In average, we see that with our products we have a result with 20-25 kilos of nitrogen per hectare. Also, this product produce when we use this product foliarly, we have effect like stimulation effect for growth. I will show you in other trials. As you can see, we would like to show you one trial from scientific station from Germany. We used two systems. One system was with mineral fertilizer. As you can see, we use nitrogen and phosphorus with a rate 170 kilos per hectare. And in this case, the best result showed us ground fix, which we used with a rate 2 kilograms per hectare. When we didn't use mineral fertilizer, the same 170 kilos per hectare, the best result showed us azotohel with a rate 3 liters per hectare. As you can see, it is we had increase in the yield around 1.5 ton on this trial, and around our increase in the yield with ground fix product was around 1 per hectare. One more trial, it is already from Czech Republic. As you can see, it is our scheme for trials. We had control place with amount of mineral fertilizer like urea 100 kilos per hectare, plus ammophos 120 kilos per hectare. As you can see with our product of azotohel, we use urea 40 kilo per hectare and ammophos 120 kilo per hectare. The same amount of mineral fertilizer we have on our other trial. As you can see, one difference we have, it is between control and our trials, it is 160 kilos of urea. But for our trials, we used azotohel one time in this trial, one time with a rate half a liter period of when we had development phase of corn 6 leaves, and other our trial with water a liter per hectare in phase of 6 leaves and before blister. And also, please look at on this table. As you can see, this corn was for silage, and as you can see from control slide, we get yield 52 tons from 1 hectare. With our products, we have around 55-56 tons per hectare. And also the same situation we have with when we calculated of dry method of yield, and also we provide our product provide us increasing the yield. It is around 5-4%. One more trial, as you can see, it is result of trial from Netherlands, and also we used our product with a rate 40 milliliters per 250 milliliters of water in per row. On plot 1 was analog, like other product with the same effect, like nitrogen fixation. As you can see, we have few indicators like NO3, and on control side was indicator 1700. With analog, we get 1800, and the best result showed us our product azotohel. It is more information from field. As you can see, in this case, we used azotohel dry formulation of azotohel. with a rate 0.15 grams, 150 grams per hectare, plus we added in tank mix liposam, it is bioadhesive, with a rate 0.3 liters per hectare. And also, as you can see, this trial was in Italy, and our crop was sorghum. As you can see on control side, from control side, we have result like 6.5 ton per hectare. From trial side, we get around 6.99 ton per hectare. It means that this complex, azoto with this rate plus liposam, provided us more than increase in the yield more than 400 kilo per hectare. And also, I would like to remind you that we used only this complex once per vegetation period, all vegetation period.
Dima, I'm sorry, can we come back to this trial? No, it's actually one of the very interesting trial of the last year. First of all, it was a dry premium version of AzotoHelp with low dosages. But could you comment in your estimation the economic effect? For example, as I understand, the cost here was more or less like maximum up to 20 euro per hectare. So what is the gain?
Yes, you're right. If I remember correctly, price for grain of sorghum last year cost around 170 euros. And I think maybe Mr. Stefano can help us with this price in Italy.
But more or less, if we take corn price, it seems like up to 200 euro, right, per ton?
Yes, it means that our this money which we spend for this complex also the help plus liposam around up to 20 euros provide us around 80 euros increase income.
So it's like 4 times more than investment. So it's really a way to preserve yield in case of arid conditions, but also in normal conditions, AzotoHelp acts somewhere similar in terms of yield on corn or sorghum, right? So please continue. Sorry for interruption.
No, thank you very much. Yes, one more trial. One more trial when we used this product as a help. As you can see on this table, we have scheme for application of this product. As you can see on, we had clear control without nitrogen. Second part, we have only urea with a rate 50 kilos of nitrogen in active substances. Third part was the same 50 kilos of nitrogen plus urea inhibitor. Fourth plot was with the same amount of urea plus azotohelp. And last plot was everything, urea inhibitor and azotohelp. And as you can see on this table, grain yield, the best complex was variant number 5 because we get the biggest yield. Also, as you can see, number of grains per 1 burn also was from last June trials. It means when we used AzotoHelp. And also weight of 1,000 grains provide us also last two variants of trial. And also previously we discussed about more about trials when we used mineral fertilizers and our product, but as you can see, in Austria we checked the efficiency of Azoto for unorganic corn. As you can see, we use this product like seed inoculation, and from control side, we get yield 1.12 ton per hectare, but our seed treatment with Azoto provide us increase in the yield plus 0.12 ton per hectare.
I would like to add, if possible, because I was present on this trial and made these photos, that this trial was also on organic seed corn for seeds, and 1 ton of seeds here could cost more than 1,000 euro. So farmer gained more than 100 euro, and cost of application was, I think, something less than 5 euro, because it's seed treatment with low dosage of Azoto. So it's Azoto seed treatment. It's maybe not the most convenient because you need to treat the seeds, but it's very economic.
Yes, but when we calculated the increase in the yield is in percent, it means we get plus around 10%.
Yeah, thank you.
So about second our bestseller, it is ground fix phosphorus and potassium mobilizer. This product we can use like total application for field. It means with your usual sprayer. And also, second way, we can use it for system in row. If your seed machine has system for application liquid compact fertilizer during sowing. And rate of application for system in row, it is around half a liter up to 1 liter per hectare. If we're talking about total application with sprayer, it is around 3-5 liter per hectare. When we use this product, we can reduce amount of mineral fertilizer up to 20%. It means that without our products, for example, you use 200 kilos of mineral fertilizer per hectare. When you use 3 liter of ground fix, you can use around 150-160 kilos of mineral fertilizer per hectare. As you can see, ground fix it is a product with complex of bacteria. We have bacillus, few species of bacillus, as you can see, Lechiniformis, subtilis. Also, we have bacteria like Megatherium and Agrobacterium pusens. These bacteria provide us more available form of phosphorus and potassium. And a little later, I also show you how this product can influence on available form of microelements. How we can check efficiency of our product. On the field, we can see better development of plants where we use our product in compare with control side where we didn't use this product. Also, this product can provide us better more available form of phosphorus and potassium, and also we can save money which we can spend for mineral fertilizer. And also the main last indicator of efficiency of ground fix it is increasing the yield for all our crops. And also, when we calculated all our results, as you can see in our last parameters, phrases, increases the degree of available phosphorus in the soil by from 16 up to 40%, potassium up to 15%. One more trial from scientific station from Agriculture University. As you can see, our scheme was control plus mineral fertilizer. Next was ground fix plus 100% of NPK. Next trial was ground fix plus 100 mineral fertilizer. As you can see, we have only one difference. In this trial, we used 3 liters per hectare. In this trial, in this variant, we used 5 liters per hectare. Also, we have variant without NPK, only with our product, with a rate 5 and 8 liters per hectare. And also, I think it is most interesting for us when we used ground fix with a rate 3 and 5 liters per hectare, but we reduced amount of NPK and we use only 70% of mineral fertilizer. As you can see from control side, we get 8.6 ton per hectare yield. When we use NPK, it provides us 11.5 ton per hectare. The best way was when we use ground fix together with NPK 100%. And also, as you can see, we have very nice result when we used 3 and 5 liter of ground fix per hectare, minus 30% of NPK. One more trial with ground fix, it is on sunflower. As you can see, I would like to draw your attention on 2 from 5 trials. It is trial number 2. As you can see, we used NPK under cultivation. NPK was 60-60-60. In this trial, number 5, we used ground fix azotohel with NPK 42-42-42. Also under cultivation. As you can see, we used lower amount of NPK, but we used our products, and we get in comparison with control, we get plus 0.6 tons per hectare. The same situation we get when we used 100% of mineral fertilizers. It means that our products, this complex ground fix plus azotohel, provide us 30% of mineral fertilizers. Also, one more trial from Serbia. On soybean, we used, as you can see, Ecostern and ground fix. Ecostern we applied in autumn, in December, sorry, and ground fix we add in spring. But we have one big difference that this complex of products provide us better result in compare with 137 kilos of UAM, urea ammonia nitrate. And if we calculated economics, our products is cheaper than this amount of mineral fertilizer, and also we get increase in the yield plus 0.3 tons per hectare. Also one more trial, as you can see, we checked ground fix plus liposam with soil herbicide. Ground fix with soil herbicide. It is this trial show us one more way for application of ground fix and ground fix with liposam. As you can see, we didn't spend more money for one more mechanical application because we used our products together with herbicides application. And also our complex was in variant number 4. It provided us a little less than half a ton increase in the yield on such crops like sunflower. Also, I think we can discuss a little more about this trial. We used ground fix 5 liter per hectare in the soil cultivation. And also we used ground fix 5 liter per hectare with soil herbicide. As you can see, both these variants provide us increase in the yield. And also we work a lot with soil analysis. It is a better way for us because in general we have recommendation for general recommendation for a rate and type of products which you can use on your fields, but for better application and more accurate, it is when we have soil analysis before application. And also, as you can see from this picture, we make mycological analysis, microbiological analysis, and agrochemical analysis. Bigger part of our partners already know about it, and also they удачно, successful provided. One more trial from scientific station from Germany. As you can see, we have control with mineral fertilizer with a rate 75%. We have trials with 100% of mineral fertilizers and different complex of our products. And also we have trials with 75% of mineral fertilizers with different complex of our products. As you can see, the best way for corn in Germany conditions provided us Azotochem, Ecostem, and ground fix with the same amount, 1 liter of Azotochem, 1 liter of Ecostem, and 1 liter of ground fix provide us more than 20 provide us more than 20 tons of grains of corn. And if you remember, I said you that I will show you how ground fix can influence on available form of microelements. As you can see from this picture, this trial was in Greece, and when we used Azotohelp and ground fix together in one pound mix for corn, we have deeper green color of leaves. It means that all processes works better from with our products, And also, as you can see, it is left side, left leaf. We have lighter color of leaves. It means that this soil, in this case, has less amount of available boron, phosphorus, potassium, and microelements. And also, one more trial from Serbia, we use the same complex of our products, like in previous slide. And for sweet corn, it provides us plus 350 kilos per hectare, increase in the yield. And also, we can calculate economic efficiency of the use of ground beef. As you can see, we show you three variant of mineral fertilizers. It is like NPK, 1, and urea. We have last year we had such price per kilo, and also, for example, we used this amount of mineral fertilizer per hectare. It means that this amount cost, as you can see, 192, 252 euro per hectare. Also, from this second table, you can see when we use ground fix, we can use mineral fertilizers minus 15%. It is the smallest amount reducing of mineral fertilizers which we can suggest you. And also we use ground pigs foliarly together with these products. As you can see, we showed you general prices per hectare. It means that in this price we have price for mineral fertilizer minus 15% plus price for ground fix. This money which we spent for hectare for mineral fertilizer and ground fix can provide us increase in the yield around 0.4 tons per hectare. These grains which we get cost 170 euros per ton. It means that this complex mineral fertilizer plus ground fix provide us increase in the yield when we calculated it in money, 68 euro per hectare. Total economic effect, we get 57.8 euros per hectare. How we calculated this amount? When we use 300 kilos of NPK per hectare, it costs 252 euros per hectare. With ground fix, it costs 262 euros per hectare. We have different 10 euro plus when we use ground fix. But ground fix provided us plus 68 euros. It means around 58 euros per hectare we get economic effect. But if our partners could know a little more about these calculations, this system, we can discuss personally. Because I have more information and also my colleague wants to show you and discuss with you other products. Last my product which we discussed with you, it is MycoFriend. It is mycorrhizal product, and also as you know, this topic is like trend of all markets. Our products with the name of microbrand has very complex content, but the main microorganism which we have in this product, it is glomus. In general, we use this product for seed treatment and for system in furrow. How we can to check the product works? It is increases in the root system when we compare root system of our plants where we use mycoplant and root system of plant without mycoplant. Also, we can see better development of plant, vegetative mass, and compare it with plants without mycoplant. A little more statistic information about products. We can use it for cereals, for corn, for sunflower, for legumes, for vegetables and horticulture crops. As you can see, for all these types of plants, we have a lot of trials. And also one more practical experience from Germany. We used all these products like ground fixers that help mycoplant for potato with this rate for each with 100% of mineral fertilizers. And also we have the same situation when we use all this product, but with 80% of mineral fertilizers. As you can see, this complex of products provided us increasing the yield in first variant and in second variant, as you can see. Also, we used mycoplant for winter wheat, for seed treatment of winter wheat. As you can see from control side, where we didn't use mycoplant, we get yield around 11.3 tons. With mycoplant for seed treatment, we get 11.8 ton, and also in this last two trials where we used liquid formulation of mycoplant, also we get increase in the yield around 2 and 400 kilos per hectare. Also, this trial can show us that mycoplant can be useful for crops in three types of mineral fertilizers, two types of mineral fertilizers and without mineral fertilizers. As you can see, we used for sunflower mycoplant 5 liters per ton. And in this case, we didn't use some fertilizers. And mycoplant provide us increasing the yield around quarter ton. As you can see, we used the same scheme for where we use mineral fertilizer, and as you can see, NPK 40-40-40, and also mycoplant provided us increasing the yield. The same situation with organomineral scheme. Mycoplant provide us increasing the yield more than 100 kilo per hectare. The same situation with potato. As you can see, mycoplant, when we use this product for seed treatment of potato, provided us increase in the yield, as you can see, plus 3 ton per hectare. And also, as you can see, amount of starch also more a little less than 800 kilos was more with microfriend. Very often we have questions how we can use liquid formulation of microfriend and also dry formulation of microfriend for seed treatment. We have a lot of protection machine, if it is correctly, for liquid complex fertilizers. We can treat this our seeds before sowing, 1 day before sowing, and also you can make treatment before when you transport of seed of grains from into seed machine, and also last way is this system in grow, when you can use complex liquid fertilizers together with microfriend in a row during sowing. With dry formulation, we have the best way. As you can see, we have 2 packages for dry formulation. It is like first package, which protect our product against sun. After that, we have a second plastic package with vacuum. As you can see, we need to make 1 hole in this package for input air in this package. After that, we mix a little of our substance. After that, we can add it in seeds jar with small amount in each jars. After that, we need to start mixing a little. After that, we can sow in, and our seeds already treated.
Dima, I would like before we continue with following products with Alexander, I would like to ask you some questions
Yeah.
from your practice. So we talked about kind of biofertilizers. We speak about AzotoHelp and nitrogen fixation, ground fix for phosphorus solubilization, about mycorrhiza, which also help to improve nutrition of plants. From your experience, what would you most likely recommend if farmer want to use less fertilizers? What you would recommend to start with? What you have a biggest confidence in?
If farmer wants to save money for mineral fertilizers, the best way is ground fix. Because we can reduce the amount of mineral fertilizers, and we can have the same or better yield together with our products, but with less amount of mineral fertilizers.
With your experience, again, talking about AzotoHelp, what way of application would you prefer? What is the most economic and efficient way to apply AzotoHelp from your side?
If we're talking about integrated system, I think the best way to use AzotoHelp foliarly, because AzotoHelp produce bacteria which we have in container of AzotoHelp and produce a lot of bioactive substances. It is natural substances like auxins, gibberellins, cytokinins, amino acids, and also vitamins. And these substances can influence on better development of root system and vegetative mass. And also can influence on photosynthetic apparatus. It means that all processes which we have in plant will be work better.
I also would like to add about economics. Really, foliar application is quite economic and competitive, take into account market situation, because, for example, with AzotoHelp on different markets in Europe, you can expect cost per hectare like for 15-20 euros per hectare, somewhere even less. But there are competitors from international companies. It's more or less could cost 40 euro plus, 40, 50, 60 euro per hectare. So we are quite competitive, and we have a lot of data in comparison of efficiency about products on the market. So we know we are quite efficient. Dima, we also didn't mention any economic side of mycorrhiza. First of all, you introduced us two forms of mycorrhiza, dry and liquid. From your personal experience, what is more convenient maybe for farmers to use, and what is the economics of this application?
I think for us, doesn't matter what types we need to use. It depends on what machinery and what way will be more convenient to use for farmer. But for me, I think it is better and faster to use dry formulation already on the field. About economics, for example, when we calculated amount per hectare of our products, for example, we need 6 liters or kilo per ton per corn. It means that around 100-150 grams of mycopren.
Up to 10 euro, I think, right?
Yes, it is per 1 hectare. And also, when we have better root system, it means that this plant with better root system can take more form of mineral of micro macro elements and also provide more water for plants.
From your experience, what yield increase could farmer expect on the corn from mycorrhization in average?
For corn, it is around 0.6, 0.8 tons per hectare increase in the yield on corn.
More or less, it's more than 100 of additional yield when you spend just 10.
Yes, it is around maybe 100 euros per hectare plus, and we spend 10 euros for product, but we don't spend more money for mechanical application.
Yeah. And even though you can even decrease some fertilization rate, but not obligatory, because even here economics is good, but you still can have some economy in nutrition.
Yeah.
So thank you, Dima. I would like to ask the audience, if you have any questions to Dima about this topic, please write in the chat. So now we have still some few short topics for Alexander and for carbon farming and preservation of efficacy of chemicals. So Alexander, would you show us some slides?
Yes, hello everyone. Do you hear me well?
We do.
Okay, that's good. So, do you see my screen?
Yes.
Yes, good. So I will go briefly with two our most well-known products, EcoStem and Liposome. So EcoStem is a product which is specifically designed for efficient decomposition of plant residues. In particular, those that are difficult to decompose, like corn and sunflower residues. So this product contains several bacteria and fungi, which together helps helps to decompose all these residues. Basically, microorganisms feed only on water-soluble substances, or while other decomposed starch, fiber, hemicellulose, lignin, and other complex carbohydrates. So this complex is quite efficient and also not only in case of plant residue decomposition, but also in neutralization of phytotoxins, and product helps to accumulate some simple humic substances in the soil, which increase level of soil fertility. So just a second. Yeah, so how to check the structures work, or how to access or see the effect of product application. So we have a few simple visual tests and a few laboratory methods. So we basically start from the checking the structure of the plant residues after a couple of months after application of the product. Also, we look at the amount of residues left when we dig the soil and check some specific plots. We check the amount of residues, and also we look at the soil conditions, color, and the second visual option is the plant development. We look at the color and how about on the vegetation itself, and also product can lead to the increase of the yield in general. So regarding the topic of carbon accumulation, carbon sequestration, company conducted several studies in Ukraine on a cornfield with application of EcoStern, and also we have some interesting scheme of trials with soil plus EcoStern, also with corn stalks or residues. And we saw from our results that carbon of labile organic compounds in substrates increased when we apply the product on residues and incorporate them into the soil. Also, we see from the several layers that the tendency of humus content accumulation is increased, as well as the soil respiration intensity improved. So, here you can see that we have different tests on different kinds of soils: podzolic soil, dark gray, chernozem, which is quite a you can meet them all around Ukraine. So with our product, we increase the soil density depending of the amount of plant residues in field and soil structure. Also, we, as I mentioned before, we influence an organic matter dynamics in time. After 4 years, we have a positive response of soil to accumulate more humus compounds. So we have conducted several year studies with a big farm in Ukraine, where we had a control site, also site with a certain amount of fertilizers per hectare, and also we tested different volumes or dosages of EcoStern or other product EcoStern trichodermine. And we see the big potential of the product in carbon accumulation. Carbon accumulation, sorry, some technical mistakes. And it shows us that that in dynamic, in time, product efficiently work, and the soil is healthy and active, and accumulates all those beneficial substances, and helps to get a better yield in the end. So EcoStern, we tested the product according to the technology Biotrex. So Biotrex is a technology with a novel indicator designed to assess the activity and functional diversity. Basically, it helps us to estimate or to monitor the healthy population of microbes and detect changes when is something new introduced into our environment or in the soil. So we conducted a test with the sterilized standardized soil and in simultaneous application of product on this soil, and we obtain interesting results of high enzymatic activity of microorganisms in the product in these specific conditions. So we also do some field tests based on the Biotrix technology with the different schemes of fertilization from 75% to 100%. We see that that if we apply the 100% amount of fertilizers, it's not really affect the soil microbiome, but when we decrease a little bit or add ecostem to the solution, we have a positive response of microorganisms, and so they are more active and providing more nutrition for plants. Also, the second test have done in Germany, and we see that when we apply product on field in different conditions, we have a good response from the microbiota, which is help us to understand if the soil is healthy or there is something negative occur. But if we compare both two variants with ecostem to the control size, we see that we most of the time have a more positive picture of soil tested. So the last product for the webinar is the liposome. Liposome is an adhesive agent which we actively use to for the situation when we want to prevent the drought of plants and for water retention. And also we use a product to increase the efficiency of biofertilizers, biologicals, and chemicals applied. So the product based on the gel or exopolysaccharides from bacteria Paenibacillus polymixa. Product has a strong fixation and abilities and help to form protective elastic grid that retains moisture. Also, one of the advantages of the products that we can operate in a wide range of temperatures, which is allow us to not only to apply product in extreme conditions, but also in case of logistics to deliver product in and it could be like fresh and ready to use on field. So one of our studies when we check the efficacy of products is when we apply liposome together with the herbicides on a tested plot in Germany on the scientific stage. So we see that single application of herbicides did not really affect the product yield, the crop yield on field. Also, when we played with the different stages, so we discovered that to be very effective to use liposome and herbicides, we have to apply it at the growing stages ES16 to reach the maximum effect, which is as a result lead to the increased yield, and farmers get additional costs because we efficiently control the weed on tested plot. So yeah, that's all I wanted to mention regarding the ecostem and liposome for today.
Alexander, could I comment? No, I'll ask you also some questions while audience thinking. Could you please return to the previous slides here? No, next about herbicides. Yeah, so here really about the economic efficiency. So if we take into account liposome in Europe is something like I don't know. Sorry, you're not. So if you take into account cost of application of liposome, it's like from with herbicide from 5 to 10 euro per hectare. what you can expect of additional value in these experiments. Here we have winter wheat, or winter rapeseed, right? So it's more or less up to 500 euros per ton. So what is the economics in these experiments from your side? Or should I help you to comment?
Yeah, please help me
Yeah,
to.
so yeah, sorry, I'm thinking about economics all the time, so I can comment. So again, more or less, cost of application in these experiments is like 5-10 euro per hectare of liposome, and you could see from increase of the yield, it's like from 200 kilos, 300 kilos of additional yield of rapeseed. So again, it's up to 100 euro and or more additional yield when you spend 5-10 euros. So it's really not about so cost of technology. It's about the preservation of the yield and earning more money. Alexander, I would like you can close the presentation, and I would like to ask you another question about EcoStern. You described us that EcoStern could be a sufficient tool in carbon farming to accelerate carbon sequestration. We have such a lot of data about it. Is it the only economic effect of the product, or you can expect something on the crops as well?
Sorry, do you mean about vegetation or development of plants? Or?
Yeah, do it have any influence on the crops which grow after application of EcoStern?
Oh, yes, it's we can also simply back to the slide when we can visually check the effect of product application, and we see, for example, in case of corn, for example, we can see more greener plants with a more how to say deep color. So it means that the product not only how to say provide more a way to accumulate carbon, but also provide a lot of nutrition by the complex of microorganisms. So we feed the plants enough to be able to get additional or increasing the yield at the end. But also, so we have actually both ways how we influence the field is soil and plants. So for soil, we saw that we increase the enzymatic activity and accumulate carbon. From the plants, we provide better nutrition, and as a result, better development and yield at the end, increase the yield.
Yeah, in a recent period, we have more and more requests about the rice straw. Do you remember any examples when EcoStern was applied on the rice straw, and what could be the effect?
Yeah, we have one test of when we applied EcoStern on rice. So I just need a couple of seconds to maybe find information to provide.
Can I respond on this question?
I think Alex can look for the slide, but here you can comment.
Yes, we have such experience with rice straw, and also contain of EcoStern very useful in this case. But we have one very good question about time of the composition of this straw, because this straw is a little more stronger, and maybe we need a little more time for good visual effect, and also when we use EcoStern, it is not only control the composition of plant residues, it is also work with soil structure. From when we use EcoStern from year to year, we have a bad condition with organic matter, bad condition with some structure of soil, and also it can influence on development of root system and land.
So talking about the economics again, are there any other let's say directions where farmer could have economic effect from EcoStern? Maybe on the example of nitrogen fertilizers. For example, I know in Ukraine there is a practice farmers use to accelerate the composition of the straw, maybe 100, 150 or different amount of like urea or UAN, UAN or other nitrogen fertilizers. What is your practice with EcoStern?
We generally we have a few strategies how to help farmers to reduce the costs of fertilizers used for plant residue decomposition, like after corn and sunflower growing crops. So we basically help them to understand that if we apply, for example, 1.5 liters of EcoStern together with 10-15 kilos of active nitrogen substances, we can not only reduce the cost, because the general application of fertilizers can be from 30 to 100 kilos or liters of nitrogen fertilizers per hectare. So when we simply change the way by introducing biological destructor plus small amount of nitrogen substances, we have the same effect and even better, because we are not only reduce the cost of application, but also we provide more benefits like healthy microbiome, carbon accumulation. So we actually by these changes, we make farmers more happy. I would say, not only in case of the economic effect, but also he has more healthy field for the next crop growing. Like in case with the rice straw, because the next crop from after the rice was the soybean. So, and when we applied a product together with nitrogen fertilizers to destroy this, to decompose plant residues, we helped the next crop, because we prepared this a big base of nutrition and beneficial some, I would say, services from EcoStern for plants to for next plants to be more efficient in field in case of intensive agriculture.
Great. So thank you, Alexander. I believe we could continue these discussions for a long time. We are already 2 hours running the webinar. I really hope that this webinar was valuable for all today our participants and for those who will see the recording. Our team did our best to prepare this information for you. So what I would like to ask to turn on your cameras for some period so that we can see your happy faces or not. It would be a kind of your feedback. And we could also, I would ask, yeah, great. So I see some guys from Bulgaria. Katya, Mladen, could you show yourself? Christina, Maria, you can also join. Great. So to make it more alive, to at least see you and make a good memory. Great. So many respectful people. So again, thank you everybody for the presentations. If you have any questions during your work, please feel free to contact our team. We are open and willing to help you and farmers everywhere in the world. Yeah. So again, thanks to everybody and have a nice end of the week.
Thank you. You too. Bye.
Thank you.
Have a good day.
Take
Goodbye.
care. See you.
Thank you. Bye-bye.